Hello and welcome to my talk on SCS kinds. I'm David Strohmaier. I'm a research associate in the computer science department at the University of Cambridge. Some of you might know me, but today all you will see of me is this, because I haven't had a haircut in 6 months. In today's talk, I'm going to talk about SCS kinds, which stands for Social-Computation-Supporting kinds. They are a subset of social kinds that support computations implemented by social groups. Throughout this talk, I will use 3 examples: departmental reimbursement form, US dollar bill, and chair of the board. Here is my plan for introducing SCS kinds. First, I'll give you a little bit of background about the social ontology debate on social kinds and about social computation. Then I'll get to the core of my account, we'll give you an example of an SCS kind, and I will present the conditions for being an SCS kind. After developing these conditions in quite some detail, I will turn to the significance of SCS kinds and tell you why I think we should care about them, not just for the sake of social ontology, but also out of practical considerations. Let's get started with the background. My talk contributes to the investigation of social kinds, where I have a very broad conception of social kinds, including everything from artifacts such as pens and papers to more abstract entities and institutions. I'm focusing on the subset of social kinds, so I'm not talking about all social kinds. I'm not the only one to do that. There are also a lot of theories about institutional kinds as a subset of social kinds. Searle worked on institutional facts or institutional kinds. Gual and Hendricks proposed another theory of institutional kinds, the rules in equilibrium theory. Insofar, I identify a subset of social kinds and argue it's very important for our purposes. I'm competing with these theories, but I'm not going to say much about these theories in my talk. Okay, what is a social computation? Roughly speaking, social computations are simply computations implemented by a group. Slightly more formally, a computational process P is a social computational process if and only if P is instantiated by a social group. To give you an example, a team of researchers engaging in a calculation is an instance of social computation. They implement a computational process as a group, not just as individual members. I'm not going to commit to a specific theory of physical computation here. I do have my favorite, which is Piccinini's account of mechanistic computation, but you can plug in pretty much any account of physical computation. But I don't want to get too much into the technical details today. Instead, I'm just going to rely on the assumption that social computations are widespread, but not every social process is a computational process. In other words, I'm also rejecting a pan-computationalism which would turn every process into a computational process. In addition to the notion of social kinds and social computation, I would also need the notion of a realizing agent. This is a technical term I introduce for the purpose of my analysis. A realizing agent is a member of a group engaging in a subcomputation for this group. Formally, a group member A is a realizing agent if and only if P is composed of the subprocess P1, P2, and so on, and at least one of these subprocesses is realized by A. A realizing agent is basically a group member that co-realizes a social computation. And with that, we are ready to go to the core of my talk. Here's an example. Departmental reimbursement form is a social kind with a function. Instances of the kind have a purpose. Departmental reimbursement forms are supposed to help departments implement more efficient accounting processes. And I'm thinking of these accounting processes as being computational processes. Importantly, the kind departmental reimbursement form figures in the cognitive processes of realizing agents. For the departmental accounting process to function properly, it is required that members of the department conceive of these sheets of paper as departmental reimbursement forms. They have to think about them as belonging to the kind. Based on that example, we are now in a place to understand the conditions for being in SCS kinds. This is the full analysis. Don't worry, this is a very complex biconditional, but we'll go through it step by step. Let's start with the top. A social kind is an SCS kind if and only if instances of K have a function that is specified with regard to social computational process P. This first part of the analysis clarifies that SCS kinds are social kinds with a function and are characterized by the content of this function. The function is that the instances of the kind are represented as belonging to the kind and subprocess of the social computations. In virtue of this representation, P, the computational process, is more powerful or efficient than the social processes Q, R, where Q, R, and so on are the most similar possible social processes where no instance of K is represented as such by the realizing agents. In other words, the representation of instances of the kind as belonging to the kind by realizing agents is difference making for the computational properties of the process P. To shed more light on this analysis, let me go through its most important parts. First, the function. When I say that SCS kinds have a function, I'm thinking here of a selectionist approach to functions, not a projection account. Roughly speaking, I'm thinking of Millikan, not of Searle. I'm thinking here that SCS kinds have their function in virtue of a selection process. These selection processes are not necessarily evolutionary selection processes. There are generalized notions of selection in the literature, such as found in Garson. The idea is that departmental reimbursement forms are instantiated because they have the trait of supporting social computations. They have been selected for this trait. Having said a bit more about what I mean by function, I need to say more about what it means for something to support a computational process. I have already talked a lot about departmental reimbursement forms, but I want to say a little bit more about how the chair of the board on the left and the US dollar bill on the right support social computations. A chair of the board has the function of making a decision process in a company more efficient or more powerful. These decision processes are paradigmatic examples of computations realized by a social group. As long as we think of these processes as computational processes, it's quite clear that chair of the board is supposed to make these processes more efficient or more powerful, make them reach an end state that they could not otherwise reach, or make them reach it more easily. The case of US dollar bills is a bit harder, because there is not one organization which US dollar bills are supposed to support. It's not just that the US dollar bills help the Federal Reserve or the US Treasury to implement social computations, but they support a far range of social computations throughout the market. There is, in fact, a literature in economics suggesting that money has a computational function, a sort of memory function. The idea is that the process implemented by markets, the computational process implemented by markets, could be either the result of introducing the SCS kind dollar bills or a memory mechanism. I hope that we have now a better sense of what it means to support a social computation. But my analysis puts a great weight on another point as well, namely that instances of SCS kinds are supposed to be represented as belonging to the kind by realizing agents. A departmental reimbursement form only fulfills its function by being represented as a departmental reimbursement form. Why do I impose this demand? This demand establishes a crucial link to human cognition. Not any kind supporting social computations or having the function to support social computations will be an SCS kind. I believe that this crucial link to human cognition establishes a distinctive contribution of SCS kinds. I think of SCS kinds as being similar to object classes in digital software programming. The idea is that just as programmers define object classes when they program in an object-oriented language, we create SCS kinds to make computational process more powerful or efficient. That is a distinctive mark of the function of SCS kinds. In virtue of this demand, a lot of kinds which might prima facie seem to be SCS kinds are excluded. Pen and paper might be taken to have the function of supporting social computations by allowing you to make inscriptions. Or one might think that the brain, leaving aside whether it's a social kind, also supports social computations. Obviously, it plays a significant role in social computations. The team of researchers and the board both rely on the brains of the members to accomplish the computations. But neither pen and paper nor the brain have this crucial link to human cognition. They are linked to human cognition, but not in the right way. It is not a representation of instances of these kinds as belonging to these kinds by realizing agents that makes a difference for the computational process, that makes them more efficient and powerful. The brain contributes in virtue of being a computer. not in virtue of being represented as being a brain. Having hopefully clarified what makes SES kinds distinctive, I turn to their practical significance. I believe that SES kinds are not just important for the study of social ontology, which is interesting in itself, but also that they are of practical significance. I propose that the historical growth of societal capacities has its roots in SES kinds innovation. For example, the creation of bureaucratic organizations is dependent on the creation of SES kinds, such as departmental reimbursement form and chair of the board. I also propose that there is still room to improve our SES kinds, that we can still innovate. By creating a theory of SES kinds, philosophers can contribute to this innovation, or at least that's what I hope. That being said, we can also critically investigate SES kinds. One might fear, for example, that SES kinds play a role in reducing human agents to negligible contributors of vast computations. I'm thinking here of a scenario roughly along the lines of Max Weber's iron cage of modernity. According to this idea, processes of rationalization reduce human agency and autonomy. The study of SES kinds can also help us to understand such problematic processes. Okay, I will now quickly summarize my talk. I have introduced SES kinds as a subset of social kinds. SES kinds are distinguished by their function, which I described as a selectionist function. Their function is to support social computations by being represented appropriately. In addition, I have suggested that SES kinds are of practical significance not just for social ontology. There is room for innovation with SES kinds, and there is room for critical investigation whether SES kinds threaten human agency and autonomy. That's it. Thank you for your attention.